Hello, in this segment I'm going to draw a straight line, and from that straight line I'm going to calculate the gradient of that straight line using this graph software. To do that, I have some data. I'm going to make them plot. It basically force versus 1 over r square plot. So to give the input of the data, I'm going to choose this insert point series. So I have that series of data. So first I'm going to take the data of 1 over r square. That's I'm going to give you the input into x-axis. Just copy and paste. And for the y-axis, I'm going to take the force for the corresponding distance of charges. Then I'm going to put that into y-axis. Now I can choose the marker or the label for this curve. I'll choose, say, that black, and also choose the black from there. Or I can choose that marker or bullet with different colors, say the red, and also the line width you can change if you want. If you click the OK, then you have to zoom out to find or re-level of your curve. So this is your curve. Actually, you have to shift that leveling to show the graph properly. So for that one, I'm going to double click on this axis. I'm going to re-level this x-axis, say from 0 to 600 and show the grade. And also for y-axis, I'll choose from 0 to, say, 85 and also show the grid. So click the OK. So this will be your curve. Now from this curve, I'm going to calculate the gradient of this curve. I can also level this axis using that text, insert text. So say the x-axis, I will give you the force. That's the force. You need to be in Newton. So this one. So I'm going to put it over here. And for the x-axis, we're plotting, say, 1 over r square. So 1 over r square. And its unit will be meter inverse square. So I give the unit in bracket is going to be the -2. So this is a your x-axis. Fine. I can also rename this level. Say that repulsive force, or the curve for repulsive force. So this is will be your bullet. Now I'm going to draw the curve for second pair of charts. So which is to add in the same curve. So I'm going to again click this insert point series. Then I'm going to give the input of data again. Say this is my x-axis data. I put over here, copy and paste. And for the second axis, which is force, would be negative because they are attractive. One charge is positive and another charge is negative. So that's why these two opposite polarity charges, they will attract each other. So I just paste over here. Then I'm going to change that bullet also. Say this color would be that, and I also change the line of this color. So this is going to be So fine. So if you click the OK, this will be your curve. You can rearrange this curve. So I can also rename this series. It should be attractive force. That's why this is a view level over here. You can also write down by the text this line for attractive. I can write that one, say repulsive force, this one will be over here, and the attractive force, which should be towards the negative y-axis. Fine. Now to find out that gradient of this curve, what you have to do, you have to first select the curve. So first I'm going to find out that gradient of this repulsive force and select that curve. Then I can use the calc button, or you can click over here. So this will give you basically that point, any particular point, and corresponding x and y value actually. So this is, you can find out the x is 1695.05 and y, the corresponding y coordinate 45.69. Then you can rearrange that value. Actually, if you rearrange, you can see over there the x and y is changing. So you can choose one point is over there, say take this value, and take another point on the curve, say that this is the second point. Then you can find out the gradient of this curve using these 2 points. By the same way, if you want to find out for attractive force, first select that curve, which is that one. Now select this point, and you can choose point. So this is the point 1, and you can take that this is the point 2. So using these 2 points, you can find out that gradient of this gradient of this attractive force. If you calculate the gradient, it would be basically something into 10 to the minus 2, which basically indicates this is actually 1 over r square law verified. You can also find out that using that gradient, you can also find out that or verify the Coulomb constant. And if you want to save this one, click the file, save as your project, give the name, say forces, and you can also export this curve as save as image as like JPG or PNG, bitmap or PDF file, whatever the format you want. You can save that one, or you can directly paste, take the copy image and paste into your doc file, so or the lab report. So that should be your curve. So that's how actually you can copy and save your work using this graph software. Thank you very much.